Hey guys, today I'm going to be going over a work problem relating a spring that you may encounter in physics or calculus 2 or anything of that nature. So let's get into the problem. So the problem here I have says that the natural length of a spring is 2 feet and let W1 or work 1 equal 4 foot-pounds, which is the work required to stretch the spring to a length of 3 feet. Then find the work W necessary to stretch the spring from 3 feet to 4 feet in length. So the first thing I'm going to do for these kind of problems is I'm going to try to understand what's going on. So it says the natural length of a spring. So we're going to draw our spring, right? And that's 2 feet in length. So this guy is 2 feet. And then it's saying that it's being stretched to a length of 3 feet. So what we're going to do is we're going to draw the spring again, but this time we're going to elongate it a little bit. And this distance to this distance is 1 foot because this entire thing is 3 foot in distance. So the change in distance basically from 2 feet to 3 feet is 1 foot, which makes sense, right? So this is what we have. So we know that the integral, from the starting length, which is 2 feet, to 3 feet equals kx dx, which equals the work done. So in any kind of spring problem like this, we can tell that the work is equal to the integral of k, which is the spring constant, times x, and integrated over the period from its original length to its stretch length. So knowing this, what we can do is we can say that we know what work is for this integral, which is 4 foot-pounds as given in the problem. So the first thing we're going to do is we're going to integrate this. So we have 4 equals the integral from 2 to 3 kx dx, and we can pull out, I'm going to make a finer tip here. So we can pull out the k. So I'm just going to leave the 4 on one side. I can pull out the k, integrate like this because k is a constant, and this integrated is x squared over 2 from 3 to 2, and then that's all being multiplied by k from here, right? So what we do now is we're going to do basic integration. So k times 3 squared over 2 minus 2 squared over 2, which gives us k times 9 over 2 minus 4 over 2, which is also equal to 5/2 k. And now we know that 5/2 k equals this 4 because we just integrated from 2 to 3 of kx dx. So now we're going to rewrite this as 4 equals 5/2 k. And from here, we can now tell that k equals 4 divided by 5/2, which equals 8 fifths. So now we know k equals 8 fifths. So that gives us our spring constant. So the thing about a spring constant, it's basically a property of the given spring, and basically it's like a resistance of the spring. So this 8 fifths, it's not going to change whatever length it's being stretched to, but it will give us the key to find the work done from any length it's stretched to. So now that we know that k equals 8 fifths, we're going to move on to find the work necessary to stretch the spring from 3 foot to 4 foot in length. So what we're going to do now, I'm going to do a different color to show you this. So the work done, as we know, equals from A to B of kx dx, and that's for any kind of spring. And we know that our starting point now is from 3 feet, and it's being moved to 4 feet. So we can rewrite this as work equals from 4 foot, from 3 foot to 4 foot in length. And we know our k value, which is 8 fits x dx. And now it's basically simple integration. We can pull out the 8 fits, integrate from 3 to 4 of x dx. We know that the integral of x is just x squared over 2. And then that's integrated from 4 to 3. And all of that's being multiplied by 8 fits. And so we get 4 squared over 2 minus 3 squared over 2, all times 8 fits. And that's going to equal 8 fits times 16 over 2 minus 9 over 2, which equals 8 fits times 7 over 2, which is equal to, these can go like this, so 28 over 5, and that's approximately 5.6, I believe, foot-pounds. And so from this, we can say that work from stretching 3 feet to 4 feet is equal to 5.6 foot-pounds. And there we go. That's our answer right there. So when approaching these problems, the most important thing to know, I'm going to show you right here. So the first step is understand what's going on. Draw a picture. That will really help you conceptualize what's going on with the spring, how it's being stretched and stuff like that. The second thing is all of these work problems regarding a spring, it's going to be work equals the integral from a to b of kx dx. And we got to know that k is spring constant, and that's never going to change. You know, sometimes the question could be posed that they give you the spring constant and you have to find the work being done, or like they may give you the spring constant and the work done. You may have to find the bounds. So like what point it's being stretched from and stuff like that. So we know that k is the spring constant. A is initial length to b, which is stretch length. And step 3, evaluate what is needed to solve integral. So you're going to evaluate what is needed to solve the integral. If you have everything, you're going to find what they give you and what they don't give you, and you will differentiate on what you need to find. In this case, we wanted to find the work being done from being stretched from 3 feet to 4 feet, so it's going to be additional stretch. So they give us the initial work and the initial length and the stretch length for that work, and then so we need to find another work being done. So evaluate what is needed to solve the integral, and then 4, find answer. So with these 4 basic steps, you can tackle almost all spring problems regarding work in Calculus 2 and physics and whatever other classes that may concern this kind of problem. But yeah, so that's how you find the work being done on a spring problem. Thank you. Have a good rest of your day.